Different types of transformers. We often take for granted the seamless flow of electricity that powers our lives. Behind this reliable energy delivery are crucial devices called transformers, working tirelessly and often unseen. These aren't the giant robots of science fiction, but rather sophisticated electrical components that play a vital role in shaping the voltage of the power we use. From the massive installations that handle bulk energy transmission to the smaller units ensuring the safety of our electronic gadgets, transformers come in a remarkable variety of forms, each tailored for a specific task. Let's explore 10 distinct types of these unsung heroes of our electrical infrastructure. Shaping the flow, power and distribution transformers. At the heart of the electrical grid lie power transformers. These behemoths are the workhorses of power generation and transmission. Imagine the vast distances electricity needs to travel from power plants to our towns and villages. Power transformers efficiently step up the generated voltage to incredibly high levels, minimizing energy loss during long-distance transmission. Conversely, at substations closer to our localities, distribution transformers take over. These are the more familiar units we might spot on utility poles or within local substations. Their crucial role is to step down the high-voltage electricity from the distribution lines to the safer, lower voltage that powers our homes, shops, and industries. Precision and protection, instrument and isolation transformers. Beyond the bulk transfer of power, other specialized transformers play critical roles. Instrument transformers, encompassing both current transformers, CTs, and potential transformers, PTs, or voltage transformers, VTs, are designed for accuracy and safety. They act as intermediaries for measuring high currents and voltages, scaling them down to levels that can be safely handled by measuring instruments and protective relays. Think of them as translators, allowing us to understand the language of high electrical quantities. On the other hand, isolation transformers prioritize safety. With a 1:1 turns ratio, they create an electrical barrier between the primary and secondary circuits. This isolation is vital for protecting both equipment and individuals from electrical shocks, while also helping to reduce electrical noise and prevent troublesome ground loops in sensitive electronic systems. Efficiency and design, auto transformers and core variations. Efficiency and design considerations lead to further variations in transformer types. Auto transformers offer a more compact and efficient solution for applications where the voltage difference between the primary and secondary sides isn't too significant. Their single winding, with a shared portion, makes them lighter and smaller for similar power ratings. When it comes to the core around which the windings are wrapped, different designs offer distinct advantages. Toroidal transformers, with their donut-shaped cores, excel in minimizing magnetic leakage and electromagnetic interference, often resulting in smaller and lighter units. In contrast, laminated core transformers, a very common type, utilize stacks of insulated steel sheets to reduce energy losses due to eddy currents, contributing to overall efficiency. Adapting to the environment, dry-type and all-immersed transformers. The environment in which a transformer operates also dictates its design. Dry-type transformers rely on air or non-flammable materials like resin for insulation and cooling. This makes them a preferred choice for indoor installations or areas where fire safety is a paramount concern. Conversely, all-immersed transformers utilize insulating oil to both cool the core and windings and provide excellent electrical insulation. Their robust cooling capabilities make them well-suited for high-power applications where significant heat can be generated. The language of voltage, step-up and step-down transformers. Finally, we can categorize transformers based on their primary function of altering voltage levels. Step-up transformers increase the voltage from the primary to the secondary winding, crucial for efficient long-distance power transmission. Conversely, step-down transformers reduce the voltage, making it suitable for end-use applications in our homes and industries. These two fundamental functions are essential at various stages of the electrical power system. In conclusion, the world of transformers is far more diverse than one might initially imagine. From the massive power transformers that form the backbone of our energy grid to the smaller, specialized units ensuring safety and efficiency in various applications, each type plays a critical role in delivering the electricity that powers our lives and economies across the globe. These silent, steadfast devices are truly the unsung heroes of our modern electrical world.